Today's lesson is about solving logarithm simultaneous equations. When you solve simultaneous equations, remember to figure out the domain for both variables. The first equation is an exponential equation, but for the second equation is a logarithm equation. For the logarithm equation, we do know for y equals log base b of x, b is greater than 0 and b is not equal to 1. For argument x, it's greater than 0. So for the second equation, we can figure out a domain for y. It's greater than 0 because y is an argument. For square root of x is the base, greater than 0 and not equal to 1. From here, we know x greater than 0 and x not equal to 1. For the first equation, we know this is an exponential equation. We can create the same base. 3 to the x squared power equals 3 to the 2y's power because 9 equals 3 to the second power. Cancel the base, x squared equals 2y. For second equation, we do know log base b of a equals log base b squared of a squared. We don't want the base is a square root. We will use this formula. Square root of x squared is x, y squared is y squared equals 3. Then add base x both sides. Y squared equals x to the third power. Let's label this is a third equation, this is a fourth equation. For third equation, we will get x squared over 2 equals y. We want to use substitution to solve this system of equation. Then we plug x squared over 2 equals y into equation 4. We will get x squared over 2 squared equals x to the third power. X to the fourth power over 4 equals x to the third power. Since we have denominator, multiply by 4 both sides to get rid of this denominator. So we have x to the fourth power equals 4x to the third power. This is a polynomial equation. So we will create equal to 0 form. X to the fourth power minus 4x to the third power equals 0. Common factor x third power, x minus 4 equals 0. So we have x1 equals 0, x2 equals 4. Check the domain. This x must be greater than 0. x1 equals 0 is not the solution. We have x2 equals 4. Then we plug back to y equals x squared over 2. Y equals 4 squared over 2 equals 8. For the domain of y is y greater than 0. Therefore, the solution will be 4, 8 to this simultaneous equation. Let's go to number 3. Still, first step, check the domain. We do know for argument of log must be greater than 0. We do know the argument of the log must be greater than 0. So we have 6x greater than 0. This is x greater than 0. So for both, we know x greater than 0 will be the domain for x. For y, from here, we know y greater than 0. From this, we know 15y minus 25 or greater than 0. Solve y greater than 25 or over 15, which means y greater than 5 over 3. So we do know the domain for x and y for these simultaneous equations. X greater than 0 and y greater than 5 over 3. Let's label, this is the first equation, this is the second equation. For the first equation, we know this is a logarithm equation. Not all logs in the equation, so we need to isolate the log on one side. Log base 2 of 6x minus 2 log base 2 of y equals 1. Then we need to condense the log. These two jump as an exponent. Log base 2, 6x over y squared equals 1. Then we will add base 2 both sides. 6x over y squared equals 2. Then cross multiply. 6x equals 2y squared divided by 2. 3x equals y squared. For second equation, still this is a logarithm equation. Not all logs in the equation. Cross the river, change sign. We need to isolate the log on one side. 1 equals log base 6 of 15y minus 25 minus log base 6 of x. So we have 1 equals log base 6, 15y minus 25 over x. Condense the log. Then we add base 6 both sides. 6 to the first power equals 6 equals 15y minus 25 over x. Cross multiply. 6x equals 15y minus 25. Then we will do the substitution. Let's label this is a third, this is a fourth equation. For the third equation, we get x equals y squared over 3. Plug into the fourth equation. 6 times y squared over 3 equals 15y minus 25. Reduce 2y squared equals 15y minus 25. So we get 2y squared equals 15y minus 25. This is a quadratic equation. We need to make equal to 0 for. Everything on the right side of the equation will move to the left side. 2y squared minus 15y plus 25 equals 0. Ninja x 50 negative 15 over 2 over 2. Negative 5 negative 10 reduce negative 5 over 1. Variable is y. So we have 2y minus 5 times y minus 5 equals 0. y1 equals 5 over 2. And y2 equals 5. Check the domain for y. Y is greater than 5 over 3. We got the y1 equals 5 over 2 and y2 equals 5, both greater than 5 over 3. These two are the solutions for y. For x1 equals, we will plug into this equation. So 5 over 2 squared over 3, that equals 25 over 4 over 3, drop down, that is 25 over 12. For x2 equals 5 squared over 3 equals 25 over 3. Then check the domain for x. X is greater than 0. That's the domain for x. Both are the solutions. Therefore, the final solution will be x1 is 25 over 12. y1 is 5 over 2. x2 is 25 over 3. y2 is 5. For system of equation, normally we will write down the solution in a coordinate form. Let's go to number 5. First of all, let's check the domain. For x, it's greater than 0 because this x is an argument. Since y to the third power is argument, we will get y to the third power greater than 0, which means y greater than 0. And also we know this is the formula log base b of a equals log base square root of b of square root of a, or equals log base b squared of a squared. The first equation, we will try to make the same base. For 49, we can do square root of 49 and square root of y squared. Square root of y squared, since y is positive, we will get y. So for the first equation, we have log base 7 of x equals log base 7 of y, so that we get x equals y. For second equation, log base 4 of y to the third power equals 7 plus, we will do the square root for base and argument, log base 4 of x. Since in this log equation, every single term is not log, isolate the log on one side, we will get log base 4 of y to the third power minus log base 4 of x equals 7. Condensing the log base 4 of y to the third power over x equals 7. Then we will add base 4 on both sides. We will get y to the third power over x equals 4 to the 7th power. Since x equals y, we can change this into y to the third power over y equals 4 to the 7th power, let's do 2 to the 14th power. Reduce y squared equals 2 to the 14th power. Then y equals 2 to the 7th power equals 128. Then x equals 128. So the solution to this system equation will be 128, 128.